Hi, my name is Darren Winterton. I'm with ST Microelectronics, and today I'm going to teach you how to make a reflectometer. A reflectometer is essentially a device that will measure the actual reflectance at 940 nanometer of any material or surface that you want to measure. Why is this useful? Well, our time-of-flight devices measure the distance of targets at 940 nanometer. The brighter the target is at 940 nanometer, the more photons we get back, the more accurate our measurements. The board package needed is the P-Nucleo 53L0A1, which includes the STM32F401 and the X-Nucleo 53L0A1. Then you'll need the step model on the ST website, and lastly you need some wire. For the printed plastic model, please paint either the inside or the outside to stop any IR light from passing through. So when taking the boards out here, we do need to have the full expansion board. But we also need to take one satellite, and we need the connector to attach it to the main board. And then we're going to take the connector off of this board, completely remove it, and this is where we're going to use our wires to solder directly from this board to this connector. To reiterate what pins they were, it's power, ground, the reset pin, the I2C SDL, and the I2C SDA. So those 5 wires are all that need to be connected. And just being careful, I did put the connector here because it's easier to use with the plastics. That I put the connector instead of normally where we put it on the top, I put it on the bottom so the wires come out easier so they're not in the way. So here, now we've successfully glued the board in using just a hot melt glue. And the board is stiff, in which you can now actually see the part is sticking through the hole in the cup. I've already pushed the wires into the connector. And then to get the board connected to the cup, you just take the pins. It's a friction fit, so you can take and just push the pins into the plastic. And actually you can see it's still pretty strong, that the cup, the friction fit is working very well. All right, now that we've finished assembling, we're ready to program the firmware on it. So to do that, you can download the reflectometer.binary file from the internet. All you have to do is plug in the board to any PC. So you have your normal C drive, but now you have a D drive called node_F401RE. We take the binary file, and you just right-click and go copy. And you go to this drive, and you hit paste. And the LED on the board will start blinking. And when it's done, it'll run the program. So you see it said CA88, so it's ready for calibration. Now that we finished putting the firmware on the board, we're ready to turn it on and calibrate it and start actually using it. So we plug in our USB cable, and it's going to take a few seconds to boot. You see CA88, which means to calibrate this unit on an 88% reflective paper. So that's what we're going to do. We have 4 charts in front of us. The first one is a calibrated 88%, 41%, 17%, and 5%. These are all calibrated for 940 nanometers to be accurate. So when we come up, you can see it's pretty close. It's about 83%, but if I push the blue button, it immediately goes to 87, possibly 88%. Now I can start using it now. If I can now go to a 41%, it's reading 40. If I go to a 17%, it's reading 16. And if I go to a 5%, it's reading 5. Now, you can also take a plain ordinary printer paper that we just stole from our printer. And if you take our unit and go up against it, you're seeing it's pretty close to 88%. So this is good enough to use for a normal calibration procedure. So if I went ahead and calibrated as this being my 88%, and my 88 is still about 88%. So this is how we build a reflectometer. All the materials that you need to build this, including the step model to have printed on a 3D printer and the firmware binary, is all located on www.st.com/timeofflight. If you have any questions on how to build this or anything like that, please contact your local sales representative and they will be happy to help you out. Have a wonderful day.